Hello and welcome to my Physics 1 Lab 3 about gravitation. The main purpose was exploring the effects of gravity in an ideal environment. Models and physics principles. We assumed that the stationary body that was doing gravity was like the center thing. So like in the first one, it was a black hole. In the second one, it was Earth. The system was the orbiting body around those things. The first time it was a mass, random mass. The other time it was the moon, and the surroundings was the stationary body. If we used Newton's law of universal gravitation for this one, F grav equals mg or gmm divided by r squared, and we used the position and velocity update functions to update position and velocity to model it. We used Python to compute as a computational model and to predict the results. Here's a brief overview of what happened. Time to show you the code. So here's code one. Basically, we were given random coordinates for our thing. This is all just stuff that they told us not to edit, so I don't know what it does. And then we come to here. Um, where is it? Here. So then this one is for the velocity initial, velocity final. We get this by just kind of taking it from what we have. Then these are the velocities, the final change in velocity. More or less, we just update the velocity and position for all of these, and then with that, we can calculate the mass of the black hole at every moment. So if we run our program, these are the masses of the black hole, and eventually it'll stop. All right, there we go. And what I did was I basically just took all these values, put it in a spreadsheet and averaged them. Um, Now we can move on to our second demo. All right, this one was a little bit more simple. Basically, this was all the visualization stuff. Then for here, um, don't want that. Basically, for all of this one, we just we found the gravitation on the ship and on the moon because both of them were orbiting, and we basically just updated the moon velocity and position and the ship velocity and position. This is all the force calculations, and then we were supposed to guess, and this is the more visualization, or this is to check the crash. And basically, we were supposed to find values of these such that it doesn't crash, and you basically get a lot of stuff. Eventually, 7 hours I crashed, but oh well. All right. So the nuances, basically, we were assuming everything's in an ideal environment. Basically, like that there's only two planets in the first one, and there's only one black hole in the second one. In real life, there's gonna be random gravities from other planets that like act on it, and so that might change minuscule amounts. And time step, we had to set a time step of our own. It's not like infinite, so like those micro miscalculations could add up over like thousands and thousands of iterations, but it really didn't make a difference here. So net for in terms of like net force is always going to be in the direction of the body, but the momentum is uh perpendicular and parallel to like the kissing circle, or like the motion, this thing of motion. So sometimes they are slightly offset. Um and this imaginary for what does it mean? Uh if we wanted to predict the motion of the entire system, we would probably need to also do a little bit of gravity calculations on the stationary object. And so the stationary object would move a little bit, and over thousands and thousands, it'd probably migrate somewhere, but we kind of just kept it still. And then for my results, basically we got the mass of the black hole to average about 1.41 times 10 to the 34, I think, kilograms. Ship's velocity was this 2.5 times 10 to the fourth meters per second, and the ship's velocity, well, that's the x direction, and the y direction was um 24,070 meters per second.